Hi, in this video, we are going to be looking at various integrals, and instead of actually evaluating these antiderivatives, we are going to just try to decide what is the most appropriate strategy to evaluate these. So I am looking at the first one here, A, and for some things I want to notice is that there's not really a great choice of factors to do parts on. It's not a rational function, so it doesn't really make sense to use partial fractions. And there's not a good substitution choice either. X squared minus 4 is a decent substitution choice, but then there is no du factor to be used to complete the substitution. So the most appropriate strategy for A is most likely trig substitution. You have a difference between you have a difference between a x squared term and a constant, which is itself a square, and hopefully by making some sort of trig substitution, we can get that to be some expression squared. So then the square root, what simplify it, using some trig identity. So for A, I would say trig substitution trig sub, use a trig identity to simplify the radical expression. For the second part, B, I have the product between a power function, x to the seventh, and sine of x, which is a trig function. Again, there is no natural substitution here, uh, but by repeatedly employing parts, we could lower the power of the x to the n term, the x to the seventh term, until it were just a constant, and then you could just anti-differentiate the remaining trig term, whether it was a sine or a cosine at that point. So this is integration by parts to repeatedly lower the x to the seventh power. In the third of these, for cosine x over sine x, there is a natural substitution here by letting u be cosine of x or be sine of x, then du would be cosine of x dx, and we would just have a 4 over u antiderivative. So substitution, let u be sine x, du is cosine x dx. And finally, we have this rational expression here, and we note that this ought to admit a natural partial fraction decomposition since the denominator is totally factorable. And so, well, that's a misnomer. All rational functions have factorable denominators, but this one is very nicely kind of pre-factored for us. So, partial fractions. It's a rational expression. Rational integrand. And then we should end up with some sort of integral that's in terms of log the absolute value x minus 1 plus something log the absolute value x minus 2 plus c. All right. Thank you very much. I will see you in the next video.